Hey y'all, let's take a look at lesson 2. We're going to do a couple things today, but make sure you have your notebook paper that you've got, written out where it's lesson 2, and we're going to do some examples here. So first off, before we do all this stuff, algebra is basically people finding out rules that work with arithmetic and numbers, and then just saying, we're going to apply this and just do it as a rule for any number, a, x, y, z, whatever. And that's what half of this algebra stuff is, just figuring out it works for real numbers. It must work for variables as well. We can just write a rule and call it something, and then we'll, illustrate it as if it's true, and it is. But let's look at this first. I want to go through the logic of this because we're going to talk about negative exponents. These things can look really intimidating in books because you got exponents, you have x's, there's negative exponents, there's small, they look so complicated in your book. So let's take a look at the actual logic behind this first. Okay, so 2 to the third power, we know what that means, right? It means 2 times 2 times 2. We don't want to have to write 2 times 2 times 2 in some book. It takes up too much space, too much possibility for error, and so on. So anyway, so 2 times 2 times 2 is 8, okay? 2 squared is 4. 2 to the first power just means 2 by itself as a factor. That's 2, and so on, okay? Before we keep going, do you notice what's happening each time with the exponent? We're going down, right? 3, 2, 1, 0, and we're still going down. -1, -2, -3, and so on. Well, the answer, you tell me what's happening with the answer. Each time, what is happening? You're going half, right? Okay. So logically, what does the answer have to be to 2 to the 0 power? Don't say 0. Each time it's going down by half. Half of 8 is 4. Half of 4 is 2. Half of 2 is 1. Okay, we'll talk more about why that's true later on. But let's keep going. All right, 2 to the -1, we're following a pattern. What's going to be the next thing? Don't say negative anything because it won't be negative anything. We're going by half each time, right? So half of 1 is a half. Okay. All right, keep going. Half of a half is a fourth. Half of a fourth is an eighth, and so on. You probably notice a kind of a pattern like this. You're going 2 to the third power is 8. But 2 to the negative third power is 1 over 8. And that is actually a rule, and this is how we're going to look at it right here. That is the rule. If you want to write that down, I'd write it down. X to the -n power, which can be anything, is the same thing as 1 over x to the +n power. In other words, you have 2 to the negative third power, which is, you can put there. That's going to be the same thing as 1 over 2 to the positive third power. 2 to the positive third, of course, is 8. So what's going to be 1 over 8? And that holds true. We're going to use that to help us solve some stuff. Now this stuff can get kind of complicated looking with all these parentheses and fractions and negatives and negative exponents and variables and all that stuff. If you'll be careful and just take a bunch of steps to make sure you do each step correctly, you'll be in good shape. If you get a few of these wrong, it's okay. Just look back at your solutions manual, which you need to make sure you have one, and because it explains all the steps that you get to get to the answer, not just the answer, but how you got there. You can look and see what you did wrong and fix it for next time. It's not that big of a deal. But you want to make sure that you get out of Saxon math. Do not go through this class and just do every other problem set. No, just do the odds sometimes. And I didn't understand what happened. No, get all of these problems correct and work on the ones that you didn't get correct and fix what you did and figure it out, and then go to the next lesson only after that. So let's look at this. 3 to the negative third power. And we know from the back definition, in other words, x to the -n is equal to 1 over x to the +n. So we can go some number to the negative third is the same thing as 1 over that number to the positive third. This is the only thing that changes as far as, negative exponents. Don't change this to -3 because that's no. Only thing that changes is the exponent value. Well, we know what 3 to the third power is, right? What 3 times 3 times 3? That's going to be 9 times 3, which is 27. So this is your answer. 3 to the negative third power is 1 over 27. Now, at some point pretty soon, you're going to not have to go through all this. You're going to realize right away. Your mind will tell you, oh, 3 to the third power is 27. So 3 to the negative third, 1 over 27. You'll just write it. Okay. All right. Let's look at this one on top right. -3 to the, in parentheses, to the -2 power. All right. Don't get all bogged down with this stuff. It's not that big of a deal. Okay. All you're doing is you're going, okay, well, that's fine. I'm going to rewrite this as 1 over, and in parentheses, make everything exactly the same except for the sign of the exponent, all right? Well, what is negative 3 to the 2 power? That means the entire, stuff in the parentheses is going to be multiplied by itself twice. Well, what is negative 3 times negative 3? Well, it's positive 9. So the answer to this is 1/9, the positive 9 down there. Okay, let's look at this one. Now here's another trick I'm going to show you. Rather than going, oh, I'm going to take this part right here, I'm going to go, well, you know what, let's do it. Let's do it first. Let's just keep the 1 the way it is. I'm just going to rewrite the 1 the way it is. Okay, now 3 to the negative 2 power, by definition, is going to be 1 over 3 to the positive 2 power, right? Well, 3 to the positive 2 power is 9, right? You tell me, what is 1 divided by 1/9? Oh, how many 1/9ths go into 1? And the answer is 9 of them do, right? That's the answer. Well, that's 3 to the 2nd power, right? Well, here's another trick you can use anytime you want to, and this will save you a lot of time and heartache, and it will clean and straighten your teeth as well. What you can do is when you see a fraction with a negative decimal or a negative exponent, you can just take that entire thing and just shoot it to the other side. If it's in the denominator, shoot it to the numerator. If it's in the numerator, shoot it down here. And what you can do is you can do exactly kind of what we did here. Everything stays the same except for the exponent sign changes. So if you did this and you moved 3 to the negative 2 up there, it would turn into 3 to the positive 2 up there, and then you would just have a 1 in the denominator. Well, 3 to the 2nd power is 9, right? We just said the answer is 9. So anytime you see something like this, let me erase that for you so you can kind of, anytime you see something like this, you can just take this, rather than going through all this rigmarole, just take this thing and go, okay, I'm moving this up here, I'm turning that into 3 to the positive 2, and then that answer is 9. Okay, I got it. And you can do that from now on, all right? Let's move on to these last two. This is where it starts looking kind of complicated. But again, don't be intimidated by this. You just keep, if you got negatives, fine. We'll deal with them one at a time. Write as many steps as you want to. Don't let this, throw you. You can imagine this, if you want to, as being over, a 1, like it is a fraction. You can either look at this like it's in a fraction, and then you move this down here, and it turns into, down here, it would look like this. It'd be the opposite of 3. Don't forget, that stays the same. The only thing that changes is this sign to the positive 2 power, and you need to have something in the numerator, so just put a 1. All right, well, the question you're asking is, let's hold off on this for a second. Well, the actual question they're asking is, what is the opposite of 3 squared? Well, 3 squared is 9. The opposite of 9 is negative 9. So this is your answer, 1 divided by negative 9. Or you can just put the negative outside the entire thing, since a positive divided by negative is a negative. So the answer is negative 1/9. Okay. The other way to deal with this, if you would like to, is to go by definition. By definition, this is 1 over the same thing, just like we said in the last page. You can do it either way. All right. Now look at this one on the bottom right. This is about as complicated as it gets, until it gets a little more complicated. No, this is as good as it gets here, right here. All right, look at all those negative signs. It gives me the willies. Okay, well, let's take a look at it. And again, you can imagine this as a fraction over 1. So your entire MO is going to be to go, okay, I'm taking this thing and I'm flipping it. I'm putting the 1 on top since there's nothing else to go along with that. I'm copying exactly the same thing as on there. Okay, that's a negative, negative. Parentheses, negative 3 in there. This gets changed. That's the only thing that gets changed. Yoink, right there. Okay, so forget this right here, right now. Let's deal with negative 3 to the 3rd power. Well, negative 3 to the 3rd power is negative 3 times negative 3 is positive 9, right? Then positive 9 times negative 3 is negative 27. So we can rewrite this thing like this. And I would suggest you do this at first for a while. Go ahead and write extra steps. I'm copying this negative right there. The answer I arrived at is negative 27. Well, what is the opposite of negative 27? Just plain old 27. So that's your answer. And there you go. Keep it simple. Do one step at a time, and you'll knock these things out. Okay. All right. Let's take a look at this. Let's do logic first, and let's look at actual numbers. You tell me what the answer to this is. What is 3 to the second power? Okay, times 3 to the first power. That's 9 times 3, right? Which is 27. Okay. How about this one? What is 2 to the fourth power? 16, right? Okay. 16 times, what is 2 to the second power? 4. 16 times 4? 10 times 4 is 40. 6 times 4 is 24. 40 plus 24 is 64. Okay? All right, look at this one. You don't know what that is? Yeah, let's take a look at these. By the way, what is 27 as a power of 3? 27 is 3 to the what power? Third, right? Okay. What is 64 as a power of 2? 2, 4, 8 times 2 is 16, times 2 is 32, times 2 is 64, right? So it's 2 to the 6th power. Okay, look at what's happening here. 3 to the second times 3 to the first is 3 to the third. 2 to the fourth times 2 to the second is 2 to the sixth. You see what's happening? What's the pattern? You're adding, right? Anytime you have the same bases and you have exponents, you can simply add these numbers, 4 and 2, or 2 and 1, or whatever, and that's going to be your actual answer. And if it works for numbers, then it works for variables too. So we can logically say that x to the m times x to the n is x to the m plus n, right? We don't even know what they are, m and plus n. We don't care. That's as far as we can go on this one. Okay. All right. And that's the concept, okay? So that's what we're going to do. We're going to add. All these, you know, again, when you look in your Algebra 2 book, this can look really intimidating. Like this, oh my gosh, look how hard this is. Oh, look at those negative exponents. These are addition problems. Can you add two numbers together? The answer is yes. Good. I'm assuming you said yes and you didn't like yell something at the screen. But yeah, that's all you're doing. You're just adding numbers. Can you add? Look at this. Let's get the x's together first. X squared, x to the negative 5, x to the positive 5, x to the 0. Can you add those numbers together? Of course you can. That's an x. I got a 2. I got negative 5. 2 plus negative 5 is negative 3. Negative 3 plus 5 is 2. 2 plus 0 is 2. There you go. All right. Of course, x to the 0 is just 1, so you can just cross that out probably because you're multiplying by 1. All right, let's try the y's. Y, and of course, if there's nothing there, it's a 1. There's a y to the negative 4, and that's all we got. So y to the 1 minus 4, which is y to the negative 3. And that's as far as you want to go. To simplify means you have one of each variable. That's it for the final answer. Okay, let's try another one. Look how complicated this looks. Oh my goodness gracious. We got division, we got exponents, we got this, we got rutabagas, I got everything in there. So anyway, all right, pause and copy this down and unpause when you're done. Okay. All right, I'm assuming you've unpaused it. Now what we're going to do is we're going to take care of the numerator first, then we're going to take care of the denominator, then we're going to move these around a little bit, and we're going to, what we could do, we could mash these, we could put everything in the denominator up to the top, then just do it as one big thing all across the numerator. You want to do that? Okay, we'll do that. I'm going to change this y to the negative 6. I'm going to move it up here. So it turns into y to the positive 6, right? X to the negative 3 gets moved up and it gets turned into x to the third power. Y to the 10 here gets moved up. It gets changed into y to the negative 10. And x to the second gets moved up and changes into x to the negative 2. Okay. Now we just have this to mess with. All right. Well, let's take care of the y's first. You know, let's do the x's first. I got an x to the 4th, x to the negative 10th, x to the 3rd, and x to the negative 2. Okay, so let's just add the numbers. That's all we're doing. This is an addition problem. That's all this is. So 4 plus negative 10 is negative 6. Negative 6 plus 3 is negative 3. Negative 3 plus negative 2 is negative 5. Okay, done with that. Let's take a look at the y's now. That's, of course, a 1. 1 plus negative 3, or 1 minus 3, is negative 2. I got negative 2 so far. Okay, negative 2 plus 5 is 3. 3 plus 6 is 9. 9 minus 10 is negative 1. And that's it. That's all. And by the way, it's possible that the back of your book will have something like this as an answer. They might say this is the answer. Well, that's fine. That's the same thing as you just wrote, because what you wrote here is this with a over 1 fraction. If you move the x to the negative 5th down there, it turns into x to the positive 5th, right? If you move the y to the negative 1 down there, it turns into y to the positive 1. Same answer, so don't be intimidated by that. Okay, all right, well, let's do the power theorem for exponents. This is the power. Now, a minute ago, we did this. We went something like 2 to the 3rd times 2 to the, 2 to the 2nd. I'm still working on my 2's and 3's. Okay, so that equals, let's see, that'll be the 2, and then 2 plus 3 is 5, and we found out, boy, that's true, so let's just make a rule out of it, okay? This is different. You see the difference between this and that one right there? Okay, this is bringing a power to a power. Well, by the way, you tell me, what is 2 squared? 4, right? What's 4 to the 3rd power? In other words, what's 4 times 4 times 4? And the answer is 16, and then 16 times 4 is 64. Okay, well, let's try this one. What is 5 squared? 25. What's 25 to the 1st power? 25. There you go. Now let's write 64 as a power of 2. A minute ago we said, oh yeah, that's 2 to the 6th power. Now let's write 25 as a power of 5, and that's going to be, of course, 5 to the 2nd power. Now you tell me what is happening here to get us here. What's happening between that 2 and the 3? It's being multiplied, right? It's not the same as this. This is 2 numbers with the same base, or excuse me, 2 bases with exponents, and you're multiplying those together, which means you're going to add the exponent values. This is multiplying or bringing a power to a power. So in that case, what you're going to do is you're going to actually multiply these 2 numbers, not add them. Same thing here. 2 times 1 is 2. It works, all right? So you tell me, what's the answer to this here? X to the m brought to the n power will be not m plus n, like these. It'll be m times n, right? We don't even have to write anything between like a dot, just mn, all right? That's our rule. So let's go ahead and look at these. You tell me what the answer is. You don't have to say the actual answer, but what is 3 to the 10th power brought to the 5th power? It's going to be 3 to the what power? Not 15th. It'd be 50, right? A power brought to a power you multiply, all right? 8 squared brought to the 9th power would be 8 to the what power? 18th. X to the 4th power brought to the 6th power is x to the 24th power. And y to the negative 2 brought to the 3rd power is y to the negative 6, right? You're multiplying that. Okay, again, I want to make sure you understand. This is not the same as this. If somebody says this, simplify that, you're going to go, okay, same bases. That's going to be y to the some power. Negative 2 plus 3 is 1, so it's just y. This is y to the negative 2 brought to the 3rd power. If you want to think of it this way, anything that is a cube like this, this means y to the negative 2 times y to the negative 2 times y to the negative 2, right? That's cubed. It's cubing something. Well, you can go right across here and go, okay, negative 2 plus negative 2 plus negative 2, negative 6. That's the proof that it works. Okay. All right, now here it goes. So take a second if you want to pause your video and copy this down, and we're going to attack this thing and knock it out here as fast as we can and accurately as we can, all right? Okay, and again, don't get too upset if you miss a few of these at first, because there's a lot going on here. And again, but don't forget, this is not a complicated, formula. This is addition and multiplication. This is all this is. This is addition and multiplication. That's all this is. All right, so let's take a look and let's simplify this. Now I'm just going to do the numerator first. I'm just going to work on that first. So here's the numerator. That's my x right there. I'm just copying it. X to the negative 3rd brought to the 2nd power is going to be x to the negative 6th. Make sure you know why. Okay, That's going to be a y. I'm copying the y. Okay, now I'm going to apply this negative third to each one of these terms in here. So x to the, if you want to say x to the 1, that's what that is. 1 times negative 3 would be x to the negative 3. And then the y, what's negative 2 times negative 3? Positive 6. There we go. And that's my numerator. All right, let's go ahead and simplify that. Let's do x's first. So x to the 1, I'll call it. So I have 1 minus 6 is negative 5. Then negative 5 minus 3 is negative 8. So this will be what I have so far, negative x to the negative 8. The y's, that's just y to the 1 times y to the 6th is y to the 7th. Okay, that good so far? That's your numerator. All right, we'll come back to that in a second. Let's knock out this denominator. Well, the denominator, y squared brought to the third power is y to the 6th power. And then y to the third power is just sitting there doing nothing useful whatsoever. X squared brought to the third power would be x to the 6th power. Okay, well, let's jam these two together. We got y to the 6th, 6 minus 3 is 3, so y to the third power. And then x to the 6th power. Okay, that's what we got so far. Now let's go ahead and simplify this, which means we have one example of an x, one example of a y. And, just for the heck of it, why don't we just make all the exponents positive. So let's bring this x to the negative 8th down to the bottom, and that will turn it into x to the, what? 8th power, right? That's gone. Now let's get this y to the third and bring this up here, which will turn the y to the third into y to the negative third, right? I'm only doing that so we end up with positive values for the exponents. So in the numerator, what is y to the 7th times y to the negative third? Y to the 4th, right? 7 minus 3. What's x to the 8th times x to the 6th? X to the 14. And that's it. That's all we got. Addition and multiplication. That's all this is. All right? Don't be intimidated by it. Okay, let's talk about circles very quickly. Area of a circle. Let's go back very quickly and review circles. This is your circle. That is the radius. This is your diameter all the way across. You have two things you need to make sure you memorize about circles. One is that a circumference is pi times the diameter. I don't know if anybody ever told you this before, but if you can take a circle and write a diameter right through the middle of it, and pretend like this is a string or something where you've got exactly on the edges of the circle. If you tack that string right here and you stretch it out, it goes to about right there, let's say. And you like loose this tack and you tack it there. Well, if you do it again, there you go, and you do it again and you unloose that one and tack it here, that diameter goes around that circle and then it ends up like right here with a little chunk left over. Well, the number of times a diameter goes around a circle, it's 3. And there's always a little chunk left over. Well, the Greeks or somebody figured out that it was 3.14, and you keep going. It's a number you can't actually make a fraction out of. But that is called pi. And for our purposes, we can just use pi if you want. Or you can use 0.14 or just use your calculator, that's fine. By the way, you need to get a good calculator with cosine, sine, and tangent functions on it. You can get them a Jot calculator at the Dollar Tree for literally $1, and it'll do everything you want for this entire year. Okay, so let's take a look. You need to memorize this. The circumference of a circle is pi, which is that it goes around 3 times and a little extra, that's that number, times the length of the diameter. There's something else you need to make sure you know as well. The area is pi times the square of the radius. Make sure you memorize those two, put those down somewhere, and make sure you have those within easy reach. Okay, well, let's take a look at what they tell us. The area of a circle is 12.2. What's the approximate circumference? Well, let's just plug this in. Area is pi times the radius squared. So we can figure it out. Let's just write it in here. The area, 12.2, is pi times the radius squared. All right, well, let's figure it out here. 12 point, let me get a calculator going here. 12.2 is pi times the radius squared. Well, what that means is 12.2 is about 3.14 times the radius squared. Well, we're going to find the radius. Let's divide each side by 3.14. So let's go 12.2 divided by 3. Let's say 1415926. I know it's a little bit extra. Okay, that's the radius squared is 3.883. 3.88, we'll call it 84. That's the radius squared. Now you're going to want to take your square root button and go, there you go. So let's just call it 2. We'll just say the radius is 2. All right? Now how are we going to find the circumference? Well, the formula for the circumference is pi times the diameter. Well, we know the radius is 2. Well, what does that make the diameter? If the radius is from here to here, the diameter, of course, would be 4, right? Now we're going to go, okay, well, fine. I'll go 4 times 3.14159, and so on. That'll be about 12.57. So there we go. And if you wanted to even put something like, you could put 4 pi as an answer. That's a fine answer. But if you wanted to go ahead and put the actual, 12.57, that's good too. So there you go. That's all you're going to do. Make sure you have those two formulas written down somewhere that you memorize them and use them. All right, let's do another one. The circumference of a circle is 8 pi. What's the area? Okay, well, let's write our two formulas. Circumference is pi times the diameter, and then area is pi times the square of the radius. The circumference is 8 pi. Well, okay, fine. Well, then this is 8 pi then. So let's rewrite this entire formula. 8 pi is equal to pi times the diameter. Well, if you look at that, both of them have the pi, so there we go. So the diameter is 8. What's the area of the circle? Well, if the diameter is 8, you tell me what the radius is. 4, right? There's a 4. If the radius is 4, the area is pi times the radius squared. Well, that'll be 4 squared. That's going to be 16 times pi. Well, we can just plop it in there if you want. 16 times 3.14, all that kind of jazz. Be about 50.27. And there you go. And again, just want you to visualize this. If this is the circle, you have to really visualize that. Boy, that's pathetic. Okay, that looks like Charlie Brown or something. Okay, anyway, here's the circle, and the radius, what we say, the radius was 4, okay? And, that means this 50.27, the meaning of that is that there are approximately 50, that's, well, I didn't quite write the, oh boy, let me do that again. Like if this is divided into chunks here, like equal chunks, then what you have is like 4-ish, somewhere around there. That means you're going to find about 50.27 squares in that circle because of the formula that tells us that is. Okay, all right. Well, let's try the practice set here, A and B. You can go ahead and pause it if you want to and try A and then come back when you're finished. So pause it, try A, and then hit unpause when you're done. Okay, well, again, the way you want to look at this is visualize this as it's a fraction, as if it were a fraction, because it is. It's over 1. So what you can do is you can go plop that down there, which means the entire thing changes. Well, only one thing changes, and that's the sign of the exponent, which turns into a positive 2. You need a 1 up here if there's nothing else up there. The question down here is, what is the opposite of 4 squared? Well, the opposite of 4 squared is the opposite of 16. So the answer to this is 1 over negative 16. And again, you could, if you want to, since a positive divided by a negative is a negative, you can just go ahead and write the negative 1/16. Okay, pause it and try B. Okay, let's try B. This is again a fraction. And you can rewrite this by going down here. The entire thing is in parentheses. The only thing that changes is the exponent sign, which is a positive 2. That's a 1. All right? So negative 4 times negative 4 is a positive 16. So that is a different answer from this right here, but very close. Okay. All right. Pause it and try C. Okay. Now, again, this is, not that big of a deal. And let's take a look at this. We can take care of this first. So x to the second power brought to the 0, we're going to multiply, right? So that's going to be 2 times 0, which is 0. Well, x to the 0 power, anything to the 0 power like that is 1. But let's just pretend like we didn't know that. We'll go ahead and write x to the 0 power. Same thing for this, right? Negative 2 times 0 is 0. Let's just pretend we didn't know that. We'll just keep it there. Okay, x to the negative 3 brought to the negative 2 is going to be x to the positive 6. And y to the 1 power, 1 times negative 2 is negative 2. So let's just clop these together real quick. So x to the 0 times x to the 6th, that's going to be x to the 0 plus 6. And y to the 0 times y to the negative 2 is y to the 0 minus 2, which is, there you go. And there's your numerator. All right, let's knock out this denominator. Y to the negative 8th times y to the 2nd is y to the negative 8 plus 2, which is y to the negative 6th. X to the 4th times x to the 3rd is x to the 7th, okay? And let's just say, you know, we want to put everything in the denominator, in the numerator, all right? If we do that, we already have x to the 6th times y to the negative 2. If I move this x to the 7th up there, it turns into x to the negative 7. And if I move y to the negative 6 up there, it turns into y to the 6th power, right? Okay, well, let's take care of the x and the x here. So x to the 6 minus 7 is the same thing as x to the negative 1, right? And then y to the negative 2 times y to the positive 6 is the same thing as, you know, negative 2 plus 6, which is y to the 4th. And there we go. That's our answer. Now, again, I want to make sure you understand. At the back of the book, you look at the back of the book, and you go, oh, no, I got this wrong, because they have this as their answer. There's nothing wrong with your answer at all. All this is a fraction over 1. Don't forget, you can move this down there, and it changes this into a positive 1, which is exactly what that is. So don't be afraid of that, okay? All right, give it a pause, and then try D, and then come back. Okay, well, the area of a circle is 49 pi. What's the circumference? Okay, well, let's go. We know the area of a circle is pi times the radius squared. Well, they tell us the thing is 49 pi. Well, fine. Instead of putting an A in there, I'll just stick a 49 pi in there. That's all right. Well, then pi is on both sides. You can divide by pi. So the radius squared is 49, which means the radius is 7, right? The square root of 49 is 7. Now they're asking, what's the circumference? Well, we know the circumference is pi times the diameter. Well, if the radius is 7, that means the diameter is 14. Pi times 14, and you can do 14 times 3.14, and I'm going to approximate here. It's going to be about 46. There we go. And that's all there is to it. Okay. All right. You guys, good luck today on the problem set, and I'll see you next time. Have a great day. We'll see you.